All right, today we're going to talk about section 4.7, the sum and difference identities. So today's objective is to use the sum and difference formulas to evaluate trigonometric functions, verify identities, and solve trigonometric equations. So we have our sum and difference identities on our note card. So if you will make sure that you have your note card out, we are going to have a little story here to help you memorize these identities. So if you have not watched the tragic trigonometric love story of Sinbad and Cosette, I need you to hit pause and I need you to go to my YouTube channel or go to your Canvas page and click on the link for Sinbad and Cosette and listen to the story of Sinbad and Cosette. I promise it's dorky, it's funny, but it will really help you learn the formulas and it will make what I'm talking about in this video make a lot more sense. All right, so just a couple things about the unit circle. A refresher course in the unit circle, when we very first learned the unit circle back in September and August, we broke it down and broke the top semicircle into 12 parts. So over here, we learned early on that this value right here was 1 pi. So when I subdivided this and I went ahead and used my 15-degree angles so that all my angles were the same size, I had 12 pieces of pi. So we talked about how this was 0 over here on the right, and I had 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12, 6 pi over 12, and I really went all the way around the circle until I had 24 pi over 12, which I also recognize as 2 pi. So we're going to have to find some common denominators in this chapter, and truly I think going back to this circle will really help you. It's in chapter 2 notes somewhere, so you can flip through until you find it. All right, so when we think about the unit circle, we have not been able to use some of these angles. So all these angles that are adjacent or right next to the horizontal and vertical axes, we don't have sine, cosine, and tangent of those special values. So even when I'm looking for combinations to form my angles, I cannot use those angles. So let's take negative 7 pi over 12. I need some special angles on my unit circle that I could take the sine, cosine, or tangent of that will add or subtract to give me negative 7 pi over 12. So if I look at quadrant 1, some of the obvious choices would be to come in here and use 3 pi and 4 pi. So I could say that negative 3 pi over 12 minus 4 pi over 12 is going to give me negative 7 pi over 12. Other things that could give me negative 7 pi over 12, here I have a 2 and a 9, so I could come over here and take 2 pi over 12 minus 9 pi over 12. That would give me negative 7 pi over 12. And let's see if you can come up with a third combination. All right, I think I found one I want to use. I'm going to use 14 and 21. So if I take 14 pi over 12 minus 21 pi over 12, I will get negative 7 pi over 12. So I want you to take a minute and I want you to find a couple combinations that add up to 13 pi over 12. And remember, you cannot use the angles adjacent to the x-axis, or the y-axis for that matter. All right, so let's look and see what we came up with. So 13 pi over 12. So here I have a 3 and a 10, so that's 13. So I could do 10 pi over 12, and I could do 3 pi over 12, and that's a combination. I could also subtract. I could use 15 and 3 and subtract. So I could do 15 pi over 12 minus 3 pi over 12. And if I am looking for one more combination, I could come over here and use, let's see, I need 13. I could use 9 and 4, so 9 pi over 12 and 4 pi over 12. So 9 pi over 12 plus 4 pi over 12 is 13 pi over 12. All right, so just remember, cannot use the angles adjacent to the x-axis, but you probably need to find a copy of this in your notes, or you can take a picture of the previous slide. All right, so find the exact value of the cosine of 5 pi over 12. So I'm going to take 5 pi over 12, and I put another copy of the circle over here because it just makes it a little bit easier. So I can't use the angles adjacent to the axis, but I need something that will add or subtract to give me 5 pi over 12. So I think I am going to use 9 pi and 4 pi for this example. So I'm going to rewrite this problem as the cosine of 9 pi over 12 minus 4 pi over 12. And I'm going to go ahead and simplify those. So 9 pi over 12 is really going to be 3 pi over 4 minus 4 pi over 12, which is really pi over 3. So now you have to remember that Cosette put this date together. So this is where the story of Sinbad and Cosette really comes into play, or you can just use your formulas. So the formula story says Cosette puts herself with her sister, and she puts Sinbad with his brother, and under no circumstance are their signs the same. So their signs are totally different. They do not like each other. The signs are different. So when I look and I plug values in at this point, this is the value of u, this is the value of v. So I have the cosine of 3 pi over 4 times the cosine of pi over 3 plus the sine of 3 pi over 4 times the sine of pi over 3. And at this point, you've got to know your unit circle. So when I think about the unit circle, you have to know your values. So the cosine of 3 pi over 4 is negative square root of 2 over 2, right here. The cosine of pi over 3 is right here. The cosine of that angle is 1/2. The sine of 3 pi over 4, so the y value right here is radical 2 over 2. And the sine of pi over 3 is square root of 3 over 2. So the better you know your unit circle, the more efficient you will be at these problems. So it looks like I have negative square root of 2 over 4 plus the square root of 6 over 4. You could leave that problem looking like that, or you could take negative 2 plus the square root of 6 over 4 and leave it like that. But at no point can you combine the square root of 2 and the square root of 6. So this will actually be your answer. If you had a calculator and you put it in radian mode and took the cosine of 5 pi over 12, and then separately you took negative square root of 2 plus the square root of 6 and divided the entire numerator by 4, you should technically get the same answer. All right, moving on to this problem. A tangent problem. So we need numbers that add up to 17 pi over 12. So again, can't use 7 because that would be way too convenient. So numbers that add or subtract to give me 17. So here you have a 9 and 8. So I think I will use 9 pi over 12 and 8 pi over 12. You can actually convert these. So if I take 9 pi over 12, that's really 3 pi over 4. And then plus 8 pi over 12, which is 2 pi over 3. So if I use my formula for tangent, tangent doesn't have a cool little story. You kind of just have to know the formula, but I just think of it as I'm going to break apart the numerator. So I'm going to take the tangent of 3 pi over 4, and I'm going to add that to the tangent of 2 pi over 3. So my numerator, it is not the distributive property. Do not call it that, but I'm just going to break apart that tangent statement. Then in my denominator, it's 1. Change the sign, and then multiply the two terms in the numerator together. So the tangent of 3 pi over 4 times the tangent of 2 pi over 3. So now it's when those shortcuts will come in a little bit handy. In my numerator, I have the tangent of 3 pi over 4. So 3 pi over 4 is right here in quadrant 2. The numerator and the denominator are the same, so you have negative 1. The tangent of 2 pi over 3, 2 pi over 3 is also in quadrant 2, so it's going to be a negative. My original problem has a plus, so I'm just going to put this in parentheses. And because my denominator is 3, this is radical 3. In my denominator, it's 1 minus, and I don't really have to think about these. I just found the tangent of 3 pi over 4 and the tangent of 2 pi over 3 in my numerator, so I am just going to rewrite the two terms from my numerator. If I clean this up, I get -1 minus the square root of 3 all over 1 minus the square root of 3. If I wanted to or needed to, I could rationalize this. I could do a lot of different things. It just kind of depends on the format. You cannot cancel these out. They are not identical. Even if you came to your numerator and you factored out a -1, you would get 1 plus the square root of 3 all over 1 minus the square root of 3. They are not the same, therefore they will not reduce. All right, so heading on to the next problem. So simplify the identity. So these problems are going backwards. So if I go too fast, hit pause to write the problem, and then we will break it down. We have the sine of 22 degrees times the cosine of 24 degrees plus the cosine of 22 degrees times the sine of 24 degrees. So if I think about this, my biggest thing is who is putting this date together? Is Sinbad putting this date together, or is Cosette putting this date together? So if I recall from the cool story of Sinbad and Cosette, Sinbad put this date together. Therefore, this is going to be a sine problem. So this is going to equal the sine. And when Sinbad puts the date together, he loves, loves, loves Cosette. So their signs are the same. So because this is a plus sign right here in the middle, this will be a plus sign right here. And I'm going to add those two angle measures together. 22 plus 24 is 46 degrees, and I am done. So these problems, we are going in reverse. So let's look at problem B. The cosine of 35 degrees times the cosine of 7 degrees plus the sine of 35 degrees times the sine of 7 degrees. So again, the question of the day, who put the date together, Sinbad or Cosette? Well, if you recall, when Cosette put the date together, Cosette puts herself with her sister. So this is going to be a cosine problem. And when Cosette puts the date together, she does not like Sinbad, so their signs are different. So since the original problem had a plus sign, the new statement's going to have a minus sign. So this is going to be cosine of 35 minus 7, which will give me the cosine of 28 degrees. Same thing happens with radians, except sometimes you might have to find a common denominator to finish out the problem. So again, who puts this date together? So if we look, we have Sinbad and Cosette. So since Sinbad actually really likes Cosette, it's obvious that Sinbad put this date together. So Sinbad put this date together. So we have a -5 pi over 6, and we have a 3 pi over 4. Sinbad, he loves Cosette. Loves, loves, loves Cosette. And so because he loves Cosette, their signs are the same. And then from here, you're going to find a common denominator and add those two numbers. So if we go through the process of finding a common denominator, the common denominator of 6 and 4 is 12. So here I'm going to multiply by 3 over 3. And here I'm going to multiply by 2 over 2. So I end up with the sine of -10 pi over 12 plus 9 pi over 12. And in the end, this is going to give me the sine of -pi over 12. All right, moving on to the last example. I want you to take a minute and I want you to work this one out. So hit pause and let's go. All right, welcome back. This is a tangent problem. So we know pretty quickly that we're going to use tangent. We have the angle pi over 4. We have the angle 5 pi over 6. And whatever sign is in the numerator is a sign from the original problem. I need to find a common denominator. Again, that common denominator is 12. So in order to turn 4 into 12, you're going to multiply by 3. And in order to turn 6 into 12, we're going to multiply by 2 over 2. So if I continue on with my simplification, I get the tangent of 3 pi over 12 plus 10 pi over 12. And if I add those two terms together, 3 pi plus 10 pi adds up to 13 pi over 12. All right, so moving on. I know how much you guys love using right triangles, so we're going to find the exact value of x minus y using right triangles. So these problems you've seen on every test, every quiz, in a different way, shape, or form. There is a lot of information in the given problem, so we need to really be able to take it out of the problem and understand what it's trying to tell us. So first thing I notice is we have a formula, sine of x minus y. This is the sum and difference formula, so we are going to have to use the story of Sinbad and Cosette. So if I go ahead and do that first, I'm going to have Sinbad putting the date together. He always puts himself with Cosette. Sinbad puts his brother with Cosette's sister. And their signs are the same because he is madly, madly, madly in love. So that's what they're trying to tell you there. So that's the first thing that we're going to do. The second thing is right here. This is telling me that I have a triangle in quadrant 1, and here I have another triangle in quadrant 1. So I basically have two reference triangles in this particular problem. I have a reference angle of angle x, and I have a reference angle of angle y. So the second thing you will need to do is you will need to sketch your triangles. Number 3. Number 3, they're telling me the sine of x is 9 over 41. So if we do the opposite side over the hypotenuse, that's what that is trying to tell us. And then the last thing is that the sine of y is 7 over 25. So opposite over hypotenuse. So I have two missing values in these triangles. I have a missing value right here, and I have a missing value right here. So I need you to hit pause, grab a calculator, use the Pythagorean theorem, and find those missing values. All right, so if you found the missing values, you realize that the first missing value was 40. So this missing value right here was 40. And the second missing value was 24. So if you did the Pythagorean theorem, and remember, I found both of those values using the world famous Pythagorean theorem. So now it's back to my formula. I am just going to use the right triangles in the picture to fill in the blanks on the formula. So if I come over here and I take the sine of x, I'm going to go over here to triangle x. I'm going to take the sine, which is opposite, over hypotenuse. So this is simply 9 over 41. And yes, that is the same thing that you have in your problem right here. So you could have taken it straight from your problem. All right, then I have the cosine of y. So I'm going to come over here to angle y, and I'm going to take the cosine of angle y, which is adjacent over hypotenuse. So this is 24 over 25. And then I'm going to subtract. And now we flip the sine of y. So now we're still using triangle y over here on the right. So triangle y, and we're going to take the sine, which is opposite over hypotenuse. And then we're going to come back over here to triangle x and take the cosine of triangle x, which is adjacent over hypotenuse. At this point, I would take your calculator and I would do the math in your calculator, because it is not a problem that you really want to do without a calculator. So I get a numerator of -64, and I get a denominator of 1025. So I don't think that simplifies. So at this point, I feel like that is the answer that we're going to use. So we will leave -64 over 1025 as our answer, and we will move on from there. If I gave you small numbers on a test, I would expect you to be able to work this by hand. However, if you have larger numbers on a test or quiz, then you will have a calculator.